All right, welcome everyone. For those who don't know me, my name is Michael Jennings. I am a senior HPC admin at Lawrence Berkeley National Laboratory. I'm also one of the developers on the Warewulf project. The Warewulf project encompasses a number of different topics, as those of you who've talked to me this week already know. Our main project is a provisioning system and management system that allows you to do stateful and stateless provisioning of a reasonably unlimited number of nodes, provides a back-end data store and an object-oriented management system, and a plug-in architecture that allows for development of additional features. Berkeley Lab is the main driver for the project, but we're also getting significant contributions from Intel and the Cluster Ready program. I know there are a good number of you who were here last year, but for those who weren't and who haven't seen this talk before, I do want to give a brief history of what the project is about. I want to keep it short so I don't bore those of you for whom this is a repeat. So the project started probably about 2 years ago. I went out looking for a health check script, and I know there are some other sites that did the same thing. The original email that kind of got the conversation going was from a guy at the University of Michigan asking for, hey, who's got a Node Health Check script that they'd like to share? And I was watching these emails roll in. I think there were a grand total of 3. And they all seemed to have something in common. Everybody had written their own. No two were even remotely alike. And there was only one that really had given any attention at all, in my perspective, to the concept of being reusable. Everybody had a problem to solve, and they went and they solved that problem for themselves and for their site, and that was the end of it. So I felt like there was a need that had arisen because of this. We could, as a community, create something together, since we're all solving essentially the same fundamental problem, just doing it in slightly different ways. If we could collaborate and agree on a common infrastructure to base our work on, and then just have differences in the details, we'd be able to capitalize on some economies of scale. And in general, we'd all be better off as a result. So there were 2 things that were needed. One was a framework. When I say a framework, I essentially mean the architecture that makes something possible, not necessarily how do you determine if this node is healthy or this node is unhealthy, but rather how can we facilitate an administrator to make that determination in a portable way, in a way that doesn't dictate to the administrator what that decision is or how that decision gets made. Simply facilitate the making of that decision. So we needed a framework, an architecture that would be able to do that. But we also needed an implementation. If I had come to the community and I had said, guys, I have this awesome Node Health Check framework. All you have to do is write everything yourself, and it'll be the greatest thing ever. Guess how many people would have used it? So I needed something that not only was a valid architecture, a valid overall solution to the problem, but something that actually could be installed and would do something intelligent, something useful with a relatively minimal amount of effort. And so that's what I set out to do. And I wanted to make it something that was relatively straightforward. Any of us in the industry we'll have our own personal preferences in terms of what scripting language we like to use and web frameworks and all these different types of tools that we like to employ. So I wanted something that was going to have a relatively low learning curve and was going to be accessible to pretty much everybody in the HPC world without getting too much into religion and politics. So I set out to write the Warewulf Node Health Check script. It's implemented in 100% pure, relatively speaking, Bash. I've been testing it with Bash 2 and 3 and 4. So it should work all the way back to even CentOS 2 if anybody still has that lying around anywhere. It's a modular design, meaning that instead of having to start from scratch to implement your own Node Health Check, essentially you just write your own pieces of the puzzle, drop them in place, and everything gets automatically loaded. And at that point, it's just a matter of choosing the configuration that you need for your site. I wanted to make sure that everything from top to bottom was very easily accessible, and so everything is straight Bash. That means that shell variables dictate the configuration, and shell directives dictate the execution. My other priority, we use a stateless provisioning system where basically all of our nodes run the exact same system image. So I didn't want to find myself in a situation where the configuration on each node had to differ, because our nodes don't differ, not from the software perspective anyway. So I wanted something where a single configuration file could drive your entire cluster. So that was the framework I set up. In terms of implementation, there were a number of different features that I personally wanted, and listening to some of the other sites talk about the way they did things or things that were important to them, I implemented a number of features as a result of those conversations and discussions as well. One of the features we offer is called detached mode. I'll talk a little bit more about that later. I just put out version 1.3 this past Friday, and the major feature for that release is support for multiple resource managers. Now I know this is Moabcon, and I don't want to go too far off the Torque Moab path, but many of us in this room do have systems that run varying resource managers. Slurm I know is supported with Moab. There may be others. And in order to broaden the community and gain greater economies of scale into some of the larger centers, I wanted to support more than just the original Torque that it was written for. So we now have full support for Slurm. There's support for SGE that was contributed, and I can't really say that we have support for LSF, but there's something there, and I'll give more details in a little bit. We have a lot of built-in checks already. So if your needs are fairly basic or fairly common, what you need may already be there. We've got checks for file systems, we've got checks for processes, we've got checks for inodes, a number of different things, all already there. If that's all you need, then it's just a matter of editing your configuration file, and you're up and running already. And of course, if your needs are more complicated, or if there's something that you need that isn't in there, it's fairly easy to extend it and write your own checks. And time permitting, I'll actually do a live demonstration of doing exactly that. And last but not least, as a programmer, I've been an open source developer for about 15 years now. And we programmers like to be able to isolate different pieces and parts of our code and test them independently. And though it wasn't part of the initial release, very, very quickly I made sure that all of the different checks had their own unit tests. And I actually even wrote unit tests for the driver script that does all the work as well. So the vast majority of the code has unit test coverage already. For those who missed my talk at SC, I know that there were people who were here last year at Moabcon, but weren't at Supercomputing. So I wanted to quickly go through the new versions between last April and November. I already mentioned unit tests, shell variables in the config file. Basically, you can put different variable settings inside your config file instead of having to set them in advance. NVIDIA HealthMon, we've got support for the HealthMon checks for GPUs. If you've got Tesla compatible GPUs in your nodes, we can check those now. Detached mode. This was an idea I got, I believe, from Brock Palin at Michigan. Basically, Torque, when it runs the health check, it runs it in a single-threaded manner, which means until that health check completes, Torque stops. Or on the mom side, the PBS mom will actually stop and wait till the health check is done. If the health check hangs or locks up for any reason at all, your mom can sit there blocking indefinitely. One of the ways that the Warewulf Node Health Check project deals with that is with a watchdog timer. You can set a timeout, say 10 or 15 seconds. If NHC is not done doing all of its checks in that amount of time, it'll actually kill itself and fail. Another potential way of dealing with it that I put in is what's called detached mode. Detached mode splits off the main Node Health Check script from the one that's going to do the check. So as soon as it starts up and reads the config, it forks off a copy of itself. And that copy goes off and runs all the checks while the main program returns back to Torque. Then the next time it runs, it picks up the results from the last time and returns those, and then runs the checks again in the background. So it's kind of a split way of doing things to minimize the amount of execution that actually has to happen while Torque blocks and all of the checks run in the background. Let's see. Then 1.2.1, they were fairly minor changes, which is why it was a .1 release. It's fairly self-explanatory, so I'll just keep going. 1.2.2 and 1.3 are the latest releases. One important new feature that we've added recently is the node range specifier. I'll describe it in a little bit more detail later, but I wanted to point that out. We now have support for an alternate password file, meaning that if Etsy password on your nodes doesn't have all of your user accounts for some reason, you can specify a fallback. That fallback can be the output of a YPCat or any number of different things. If you don't want to do that, there are some sites that want to talk to something like LDAP or NIS directly. We also support fallback of using the getInt command. So if it can't find a user ID through the password file or the fallback password file, it'll call getInt. In the latest version, we did a lot of improvements for detached mode. As I said, we added support for Slurm, SGE, and LSF somewhat. SGE uses a concept of a load sensor, and we can now be a load sensor. LSF is basically just online and offline support at this point. We've got some improved checks. For those of you who've used the product before, if you're looking at any of the memory checks, we now support byte suffixes for those, and you can specify device name when you're checking the InfiniBand. We have some new checks that I'll go over in detail a little bit later. One set is for looking at the DMI information, or SMBIOS, pick your term. And the others look at inodes, file system inodes. If you work in computational biology at all, you've probably run into a whole bunch of inodes on a file system before. You've probably likely run out of them before. So that will help to address that scenario. And then there's a check here at the bottom where you can actually look at a file and do matches on the contents of that file. For example, if you wanted to match against your torque config, check and make sure you've got a particular directive in there. Are there any questions so far? It was very important to me to make sure that the Node Health Check was very easy to get up and running. So I wanted to provide a quick start guide to illustrate the point. There's really not that much to it. You download the product, first of all. You can either get a tarball from this location here, or we also have RPMs for RHEL 5 and RHEL 6 and clones thereof. You can get those here as well. Or if you prefer, we have the Warewulf project as a whole has Yum repositories for RHEL 5 and RHEL 6. We provide you with .repo files that you can download to your Yum directory, and then you can just do Yum install Warewulf NHC, and you're done. So once you've done the install, the next step then is to edit the configuration file. I'm going to go through the config in detail in just a little bit, and it's actually pretty straightforward. Then once your configuration is ready to go, all you have to do is configure whatever your launch mechanism is. Usually that's going to be a resource manager, be it Torque, Slurm, whatever. But it doesn't have to be. There are a lot of sites that prefer to run out of cron, and I learned a couple weeks ago, I think, that there's one site in particular who's running 2 copies of Node Health Check. One that runs through Torque that does a few very basic checks that don't take very long for purposes of making sure that jobs don't fail, but they also use it as more of a general monitoring tool to do notifications, and that they run out of cron, so they actually do both. I put little notes in here about how each of the different ones is handled. We had a user contribute a cron script that acts as a wrapper, so every 5 minutes you don't get an email for the exact same problem. You can use that or not. Works either way. Torque, everybody probably knows already. Node check script and node check interval. Slurm is basically the same thing, only the directives are different. Health check program and health check interval. For SGE, as I said, we act as a load sensor. The way SGE doesn't really have a concept of a health check script the way Torque and Slurm do, but what they have is a generic load sensor where they'll sit there and send periodic run commands to the script and then expect output back. So Node Health Check can now be one of those sensors and return information that way. And for LSF, right now you have to run it from cron, but I'm working on that. I don't know if anybody in here uses LSF and would be interested in giving this a try. If so, I'd like to talk to you. But right now I'm just kind of doing everything based on reading documentation on the web. So the Node Health Check configuration defaults to the path that you see here. And the general syntax is pretty simple. The first thing you have on every line of the configuration file, apart from comments obviously, is a host mask. The host mask determines whether or not each individual node will run that check. So as it parses the configuration file, it compares the host mask that you've specified to whatever its host name is. If it matches, it runs that check. If it doesn't match, it skips it and moves on. So only those checks that match the current node will actually be run. Everything else gets ignored. So you can have one single config file that applies to all of your nodes, and you can differentiate through the use of the host mask. There's 3 separate mask types that we allow. The glob, which is just wildcards. If you want to match all of your nodes, the easiest way to do that is simply with a star. And then you can use any type of glob expression you want. Now, because regular expressions and globs both use some of the same characters, we had to have a way to differentiate. So for regular expressions, you have to have a slash on both sides. If you've ever used Perl, you'll be used to that already. So you can use a regular expression to match against your nodes. Or we have a new feature. John Hanks from Utah actually contributed this to the project. Again, since the wildcard characters are common, we had to have yet another differentiator. So for the range expression, we use braces. And you can have one range expression per item, and you can have as many as you want separated by commas. One slight caveat, you cannot have a comma inside the square brackets. That's one of the deficiencies, if you will, of the expression parser. But in most cases, you don't really need it. You can express it a different way, as you see here. After the host mask, we have a double pipe, and then we have stuff. And that stuff is basically arbitrary. The Node Health Check driver script doesn't actually care what comes after the double pipe. It doesn't even see it. Everything is parsed by bash. So this allows us the ability to set shell variables. We can set variables for all hosts using the star, or we can set different variables on different nodes based on different host masks. If you wanted to use one resource manager on one set of nodes and another resource manager on another set of nodes, you could do that. In theory, you could use the same config file for every cluster that you own. We can also run checks, obviously. That's kind of what we're doing here, by specifying the check name and any options that that check requires. All of the checks that come with the tarball for the project are bash functions. They work very well, so we encourage people, if you're going to write checks of your own, that you do it that way, but you don't have to. And since it's fairly arbitrary bash, you can put complicated stuff with booleans and expressions and things that happen on certain dates in April. But you probably shouldn't do that. But you can. So let's take a look at some example configuration directives. Now, I have to say up front, this is not a real configuration file. There's actually some stuff in here that's pretty contrived. But I wanted to give basically some example of all of the different checks that are possible. So the first thing we typically do is we set up all our variables. There are a number of variables, a list about that long, that you can use to configure different things about Node Health Check. I'll give you the webpage URL at the end that has a complete list of all of the variables that you can set, what the defaults are, what they all mean, etc. I just have a few basic ones here. The most obvious one is path. You can set that just as you would expect, and it does exactly what you would expect it to. This up here, NHC RM, that's our resource manager directive. PBS means torque, obviously. And then max_sys_UID is just the numerical UID that represents where the delineation is between system users and regular users on your distribution. For Red Hat Enterprise, it's 499 to 500. If memory serves, Debian uses 1,000 for the regular user count, so you'd set it to 999 on a Debian box. The next set of checks we have are DMI checks. This one of the very first investigations into Node Health Check I did was with an absolutely brilliant engineer at LBNL, a guy named Darrell. He's forgotten more about prescriptive maintenance than I know, but he taught me a lot. And this was one of the things that he used in his health checks that I hadn't even thought about. But there's a lot of good info that you can get out of the DMIDecode command. And he used it to check things like BIOS versions. And that hadn't even occurred to me, but when I saw it, I was like, that's great. Now, how do I do that? So we have two different options for checking the DMIDecode data. And the reason we have two is because one of them is intelligent but takes longer. The other one is dumb but is very fast. One of the things you'll notice when you work with the Warewulf Node Health Check is that I try very hard to only make you pay a penalty once if you're going to pay a penalty. For example, when you run the df command in order to get file system data, rather than running it on the single file system that you're interested in to get those numbers and then having to run it again on the next file system and again on the next file system, that's a lot of forking and execing, and that takes time, that can hang, and it's not efficient to do it that way. So what I do instead is I do one big run, I save all of the output, and I reuse it. So once you take the hit up front for doing one of the DF checks, you can do as many as you want because you've already taken the hit. The same basically is true with these two, with the caveat that if you use this check and only this check, the raw data match, you'll only take the hit for running DMIDecode. If you want to do the regular data match that has the intelligence built in, it calls the function for raw to run DMIDecode, so you won't take that hit again, but you will take a hit for doing the parsing. Because what it does, if you've ever seen the output of DMIDecode, there's a handle and a type, and then there's an indent. And then there's a bunch of different attributes, and then you'll come across another header, and there will be another level of indent. And you can have, I've seen up to 3 or 4 different levels of indentation. And what you end up with at the very end of the line can be very, very little. Like it may just say speed : 1600. And if all you're matching against is that speed : 1600, if you're just matching against a line blindly, you have no context. So in order to provide context, NHC will actually go through and apply each of those headers onto the line. So instead of just an indent, you'll have memory information, : capabilities, : and then the information that was actually on the line. So it does some intelligent things. It's described in more detail on the website if you're still not clear about how that works. But you can actually specify a particular handle or a particular type to narrow down where you're trying to do those matches. The benefit is you won't get false positives from other sections in the DMIDecode output that you weren't counting on. The cost is it takes a little bit more time to parse. So my first example here is exactly what I said was the payoff for this particular check. I'm checking the version of the BIOS. Everybody knows when you're trying to apply a BIOS update across a couple thousand nodes, chances are 1 or 2 of them are going to fail. This gives you a way to make sure that A, you didn't miss anything, and perhaps more importantly, B, if you ship out a motherboard that went bad to your vendor and they ship you a replacement, who knows what it's going to be running by the time you throw that in there. This allows you the ability to make assertions about your environment and keep jobs from running on nodes that don't satisfy those assertions, this being a way of doing that. So if you looked at the actual raw DMIDecode output, you would see a header that said BIOS information, and then somewhere down on a subsequent line, there would be a couple tab characters, and then it would say version : 2.0.1. So this just shows you how it propagates that column header down the list and actually fills it out on the line to do the match. An alternate way of doing it is here. You can specify a type, which is that very first column header. There's also a concept of a handle in DMIDecode. Each record set has its own numeric handle, and you can specify with the -H option which one you're interested in matching against if you want. And then, of course, there's the raw data match, which just blindly takes the output and matches against it line by line. Another new check we have down here at the bottom. If you notice this character, I used that a few times because I wanted a font big enough to be legible, but there's only so much you can fit across the screen on a legible font, so I tried to mark where I had to continue lines. But this has to be all on the same line. Everything is parsed line by line, so there's no such thing as a line continuation. We, in our environment, have found it useful to make assertions about the torque configuration, because when you install new torque RPMs, if there isn't a config file already there, or in our environment we have it in a different location, it will install a default, which basically says PBS Server localhost. And we've had situations where a node will boot up and it will say PBS Server localhost, and it'll start trying to talk to itself, which not good for users, not good for jobs. So I came up with the idea of, hey, let's write a check to look at the torque config, make sure it's what it should be. But I don't like doing anything the simple way. So I figured, well, if we're going to do that, why don't we allow looking at any arbitrary file and making arbitrary assertions about it? And so that's what I did. You basically specify one file, in this case the mom config, and then you can specify any number of matches against the contents of that file. In order for the check to pass, all of those expressions have to match. So if any one of them fails, the check fails, the node gets marked down. And when it hits a failure, it stops. So it will tell you what that first failed expression is. That doesn't mean that any of the subsequent ones wouldn't have also failed. It just tells you the first one that did. So in this case, we're looking at the value of PBS server, and we're looking to make sure that we set spool as final name to be true. If you want it to be thorough and pedantic, you would want to check for things like true and true in all caps and all the different variations that you can have there, but I'm being simple and trying to keep it not too wide. Another thing we can use this particular check for is to look at the contents of the password file. Make sure that root has an account. When you're using provisioning systems that provision password files and parts of password files out to your nodes, it can happen on occasion that your password file gets truncated, and all of a sudden not only have your users gone away, root has gone away too. So this allows us to check and make sure that root is still there, that the password file is still valid. And I just stuck another one in there. SSHD is a privilege separation account, also a good thing to check for. Any questions? I know that DMI stuff is kind of dry, but hopefully it was relatively clear. Yes. Yes. As I said, NHC is all native. Other than the commands that it runs to gather data, everything is all native bash.
You should look at the scripts. They're impressive.
Thank you. I appreciate that.
This is basically lexical analysis for written in bash. So it's like a flex file.
I'm going to have to speed up. I'm told I have only 10 minutes left. So that's kind of scary. I have a lot to could cover. We have some file system checks that we can check to see if a file system is mounted read-write. A lot of times if a file system has errors, it will remount itself read-only. This allows you to check for that. We hit that a lot with temp. Users write to temp during their jobs. They like using it as local scratch for some reason. Something goes wrong. It's ext3, and it remounts itself read-only, and then jobs start failing because OpenMPI uses /temp to do real work. So we have to make sure that if that happens, no more jobs get scheduled to that node. Otherwise, they're all going to fail. And so we have a check for that in there. Moving on, you can do matches against the mount options as well. We have hit problems where something will be mounted over NFSv4 and suddenly root won't be root anymore. So we have a check for that. This is how we do that. Let's see, file systems. This is pretty self-explanatory. You can do used or free space as a percentage as well as a raw size. And then size, of course, is a raw size, but you can have a minimum and a maximum if you choose. We also have checks for inodes. Basically, the rules are the same. Hardware checks, we can check for CPU. This is a number of sockets, number of physical cores, number of virtual cores, or threads, or hyper-threading, however you want to term it. All of the basic checks that you would expect for physical memory, total memory, and swap space are there. Notice how I have the G. That's brand new. It used to be that you had to do all the math and write out that entire number yourself. No more. You're welcome. Same basic thing down here. Looking only.
I think that in the style of torque itself, you should actually have to specify that in K.
You did. Now you don't. I like it better this way, sorry. Yeah, checks for free space basically work the exact same way. These are minimum and maximum. If you want to leave one blank, if you only want to check for a maximum, just make sure you have empty single quotes for the first one, because you can't really leave a blank space in bash. So you have to have an empty parameter, and it knows empty means skip it. And that applies in general. Networks, we have Ethernet support. You can check for an interface. You can't yet check for IP address because there's not a good way that I know of to do that in only shell. InfiniBand, though, you can check for a device and the speed. And then for those of you still using MirrorNet or MirrorNet 10G, we have support for that as well. NVIDIA HealthMon is pretty straightforward. For completeness, I threw it in there, but it doesn't really take any parameters, so you just run it and it works or it doesn't. Blacklist is fairly new. You can actually blacklist particular processes. In this case, if there's an SSHD running that's not owned by root, then there's a user who's on this node who shouldn't be, and we blacklist that. This one checks to make sure that SSHD as root is running. Self-explanatory. I'm going to skip this one because I didn't write it and I don't have a thorough understanding of it. It was written by one of our brilliant engineers on our team. It basically looks for a NUMA imbalance on your node, but the particulars of the syntax I'm not real clear on, but it's explained on the website. This checks to make sure that all of the users on your system are authorized to be there. It uses basically Troy's technique this one uses Troy's technique for verifying which users are allowed to run jobs on the node. And anybody who's not allowed to run jobs on the node and who's not in your list of authorized users, it can kill them. It can log or syslog that, or it can fail the node. Any of those is valid, or all of them. You can do all of them if you want. Okay, so how much time do I have?
We do have a breakout of this, so as long as everyone's
Well, I can do this as a live demo, or I have some slides where I just show what I would have done had it been a live demo. So we can go either way. It's kind of up to you guys. You like live demos? Anybody object? Okay. Let's see here. Okay. So this is my workstation. You'll notice I have the Warewulf rel6 repo file. So all I have to do in theory is yum install it. No. Google Earth is not a dependency. It's just one of my repositories. Wow, that would be scary, wouldn't it? Sorry, no OpenGL. Your node is unhealthy. Okay, so now we've got it installed. So we'll take a look at the config file here. The default was intended to be mostly out of the box valid, but not entirely as a proof of concept. It may or may not work. This, for example, won't work on my workstation. So I'm going to go through and I'm going to update this for this particular box. Oops. I love backspace delete problems. And I think that should almost do it. Okay. So at this point, all my checks pass. Now, I happen to have torque set up already, but I don't have NHC configured. So what I'm going to do is go in and configure it real quick. Now, for purposes of this demo, I'm going to do something stupid. A better value here is going to be something like this. That will run it basically every 3-ish minutes, depending on your mom interval, plus every time a job wants to start, plus every time a job finishes.
So the 5 is 5 intervals.
5 is 5 intervals. The interval by default is 45 seconds. Last time I tried to change it to 60, it didn't work, but I didn't feel like debugging it, so it's every 45 seconds is. But as I said, for purposes of this demo, we're going to do something stupid. And if everything went according to plan, we should now have 2 runs of NHC in the log file, and yes, we do. Any questions so far? At this point, it's configured and up and running, at least in a basic manner. So that's pretty much all there is to it to get started. Now, what happens if there's something that you want to look at that there's not a check written for. Up to this point, and one of the reasons that I wanted to do this demo, the solution has tended to be, hey, maybe Michael will write one. Which is nice, but kind of defeats the purpose. So I wanted to try and illustrate that it's pretty straightforward to actually write your own. So I'm going to do exactly that, time permitting, of course. So all of the stuff for running checks is currently in Etsy NHC scripts. All of the stuff that comes with it, other than common, starts with www. For your site, you can say something like local, or you could say NERSC or whatever your site happens to be, and then name it something. I want to look at the load average, so I'm going to call it load average. Now, the best way from a bash perspective to get the load average is from proc load average. So if we look at this file, we've got basically 5 pieces of information. Well, 6. We've got the 1 minute, 5 minute, and 15 minute load averages. We've also got the number of running processes and the number of total processes on the system. This is the process ID of the last process that ran. We don't really care about that, but it's there. So when this backspace thing is really going to kill me. So when I write checks, I like to start with a gather data function. And the job of the gather data function is to gather the data that I'm going to use later. And I have some sort of sentinel check so that I only have to run this once. I also like to pre-declare my variables. Because I'm just like that. So I want to read an array in from the proc load average file. Now, if we remember what was in our load average file, there were 5 space-separated elements. Now, what the heck did I just do? If you remember, the 4th item on the line was the number of running processes, a slash, and the number of total processes. So basically, I took that same term, and I'm using bash to parse out each side of that slash. On the first one, I'm replacing the slash and everything after it with nothing. The second one, I'm replacing the slash and everything before it with nothing. Pretty simple. This gets rid of the extra information in my load average array that I don't need, so now my array is going to be 1 minute, 5 minute, and 15 minute load averages. So there's my function to get my data. Now I need a function that will be my check. First thing I want to do is make sure that I have the data gathered. The easiest way to do that if I have 0 total processes running on my node, that can't actually happen. So that tells me I haven't run my gather function yet. Make sense? Up at the very top. Okay, so once I have my data, then I just need to evaluate it. For this check, I'm going to allow the user to pass 1, 5, and 15-minute load average limits to the check. Interesting good, I hope.
Yes, very interesting.
Okay, so for each of the parameters that were passed, if the user passed something that's not empty, and it's higher than, and the current load average is higher or equal to the limit that the user specified, basically we print out the message telling them what the average is, what the limit they specified was, and then we give an error. If we get to this point, we've succeeded. And that's it. Now all we have to do is put it in the config file. Now, just because my box isn't doing a whole heck of a lot, I'm going to use arbitrarily low limits. Done.
Okay, now check the other case.
Which other case?
Just give it a limit that's higher than what you're expecting.
Oops, wrong file, sorry. Hang on. do something more realistic. Not for a 16-core node. Generally, our rule of thumb is if the load exceeds twice the number of cores you have, that's when you have a problem. Generally, we flag those. We have a little graphical thing. Those nodes show up in orange. And typically what happened was a user started a massively parallel process using MPI and forgot to actually distribute the processes, or it's spawning that number of threads. So for every process on the node that they started, it's an 8-core node, they started 8 processes. Well, each of those 8 processes then decides to spawn 8 threads. So you have 64 threads running on an 8-core node. We see that type of thing fairly regularly. Any questions? Okay, go ahead.
How are I'm taking a guess that you get feedback on this. So how are most people running this? Are they doing it as a cron job? Are they doing it at job start, job end? Or?
Most people are running it through Torque or their respective resource manager, and they're doing it at minimum at job start and job end. I will give you one word of caution, though.
That would, however, be like after the prologue and before the epilogue, right?
I believe so. If you use detached mode, make sure that you aren't just running at job start and job end. Or if you are, you have to take other actions, because if you remember about detached mode, by default, when it first runs, if there's no state file to work from, it will return success, and it won't catch any problems until the next execution. So if you're using detached mode, you have to be careful about that. Make sure you run it periodically. Otherwise, you're going to have...
Calling it from like an epilogue or a prologue?
I don't know.
I want to make sure the stuff that happens in those 2 files actually happens.
I don't know of anyone using it in that way. But ask on the mailing list. Most of the people who are using it are either on the Torque mailing list or on the Warewulf mailing list. So feel free to send an email and ask. Any other questions? Yep. Hey, Bill. For performance of the script itself?
No, performance of the actual components to see how that changes over time.
Not currently. It's not really intended as a metrics gathering tool. There are other tools that do a much better job of that. This is more of a, yes, I can run a job, no, I can't run a job. Certainly there are data that you could gather over time of health and unhealth, but something like that, Ganglio would probably be, or Nagios would probably be a better choice. But it certainly doesn't stop someone from adding a feature like that in. It has the architecture to do it. It's just that's not there at the moment. I just want to say real quick, I have done 2 previous talks. If you're interested in watching those, the links are on YouTube. Yay, Rich. If you go to Rich Report on YouTube, he's the one who provided the Supercomputing 2012 video. The first one is on the Adaptive Computing Moabcon 2012 media page. You can get the first one from there. And if you need any help or have any questions, the documentation here is extremely thorough, a lot more thorough than I have had the opportunity to be. So it's definitely worth a read. And the email lists, addresses are there. Thank you.